we're going to finally move on to our 10th and final case. I hope it's actually the 10th again, but yes, we're talking about proving that points are collinear. Now, first of all, if you're wondering what collinear is, let me write it out big here. So collinear. Now, I want you to notice this very beautiful part which says line, and this other important part that says co. We can ignore the lar for now, but yes, co means same or together. You know, cooperate, co something, you're together, it's the same, etc. Line is a line. So here what I'm trying to say is that we're trying to prove that points lie on the same line. So yes, how to prove that 3 points are collinear. In order to understand this, I can tell you the rule right away, but I want you to visualize it. So let me here draw you a huge graph, and let me draw 3 points. This is 1, this is 2, actually this is 2, and this is 3. I don't want pink, I want green. And this is 3. Now if you don't notice, I intended to make them lie in a straight line, but you're not supposed to know that until you prove it, because I need to prove it. Now this is point A, this is point B, and this is point C. If we want to draw their position vectors, then this is, let me just use the corresponding colors. So this is A, this is B, and this is C. There we go. Now, if we want to prove that they are on the same line, we want to prove that AB are the same line as BC. So we want to prove that this is exactly the same as this, because that's the line they all lie on. Now it's good, it's easy. The next part is how to prove that these are the same line. Now if this and these are the same line, then they probably have the same slope. And if they have the same slope, there has to be the same ratio between their i's and their j's and even their k's. And that is precisely what we do. For points A, B, and C, we determine 2 vectors, AB and AC or BC. And then we're supposing that none are 0. We're trying to find if there is a constant that allows AB and AC to be like parallel. So in other words, let me give you an example here in order to understand. So if we're given here, if we're given an example, I'm just gonna cut to the chase. It's actually a long past paper question, but it's given that our B is 5, 15, and 1. And we also know points A and B. A is actually, A and C, and P. A is 0, -5, and 11, and P is 2, 3, 7. Now we want to prove that these are collinear. So first of all, we need to find the vectors they make. So first, let's say we're going to take AP, and we're going to say that AP is actually PO plus OP. It's actually it's OA. No, it's AO. Anyway, sorry. So it's AO plus OP. And what we do is we're going to do the negative of A, so plus the positive of B. So -0 plus 2 is 2, -5 is 5, plus 3 is 8, and this is going to be -4. And then we're going to find another one, so like a part of it, so we're going to go for PB. That means PO plus OB, and that would give us 33, 12, and -6, I guess. So PO, that's -7, plus 1 is -6, yes. So now we've got the 2 vectors as we said we should. The second part is to prove that they're of the same ratio, and that is what I meant by finding if there's a lambda that makes them parallel. So we want to multiply 2 by something to get 3. we want to multiply, we need to prove that there's a ratio. So we have 2 to 3 for the I, and then we have 8 to 12 for the J, and then we have -4 to -6 for the Z. Now, if we want to simplify, this is negative goes with negative. 4 over 3 is 2 over 3. 8 over 12 divide each by 4. This is going to be 2 over 3, and this is simply 2 over 3. In other words, they are actually they have the same direction because they have the same exact ratio between their i's and j's and k's, and that means that they are collinear. And this is simply how you prove collinearity. What you're trying to show is that this actually has the same ratio as this, excuse the green, and like the same ratio in order to have the same direction, the same slope, to prove that they're the same line, and to prove that you're actually talking about these lines. You connect them and you find it's either AB, BA, BC, or AC, whichever. But in the end, we prove the same thing. And by that, we're going to be done with vectors completely, all their cases, all their properties, and I know they're endless, but yes. Now let me, instead of our tips and tricks, which is, the tip is to wrap up. Why is it that? Because again, as you saw, there are many properties, many cases, but in the end, the most important part was to know your rules. And that is what we did. So what we did is that we spoke about what a vector is compared to a scalar quantity. We described how you represent the vectors and how you do it with the arrows on top. Never forget your arrows no matter what. We spoke about the properties of vectors, how we add them, the triangle rule, how subtraction is negative addition, and then we spoke about how you can add two vectors to get 0 because they start where they end, so PQ plus QP. We spoke about how to find that they are parallel by finding the lambda constant between them in order to keep the ratio between I, J, and K. And then we proved how vectors can be equal in a very long and nice tutorial, and we explained another example that's specifically about it. Then we spoke about position vectors again, which was simply going from the origin to a point, and then the modulus, which is the magnitude using Pythagorean. We spoke about unit vectors, which is a vector with a modulus 1, and its importance. Then we went into our cases. We spoke about how to use Cartesian components in order to find modulus and positions. And then we used to find the distance between 2 points, again, similarly with the difference between the x1 minus x2 squared, and same for y and k, and all that under the square root. We spoke about a very important concept called the scalar or the dot product, and we used the unit vectors. We found the angles between vectors. We proved how vectors can be parallel or perpendicular, and then we applied all these to straight lines after showing you how to find the straight line equation of a vector using two methods, keeping in mind the importance of direction and position vectors. After we did that, and the angles and all that, we determined if 3 points are actually collinear, and by that we were done completely with vectors. So revise your rules, and that would make you good to go for an A star. Always focus, make sure you don't commit any horribly heart-killing calculation mistakes, because it's not worth losing the marks, and because you watched this tutorial, and it should be enough to guarantee you an A star. Keep up for more questions to solve, and thank you for watching us on our C4 tutorials, and see you in the next